this is our assignment for the database management system. This was created by students Elina Kravchenko, student number 220844, Sangita Tamang 220056, and Nigam Kumar, student number 216469. So the background of our project is Australian manufacturing company, AMCA. It requires a database system to manage the employees, products, suppliers, patrons, and their orders. So this company has many stores in different cities across Australia. Each store has many departments, which is the same for every store. And each store has a manager, which takes care of the entire store. Each department has a supervisor and employees. And there are two types of employees, which are casual and full-time. They also get annual packages of salary, and casual workers, they get paid on hourly basis. There are many suppliers associated with this organization, and who supply different products. And records of the products is mentioned as in inventory in stores. And customers order from a store, and the concept of fulfilling the orders from different stores in any of the product is unavailable in the internet store, is not applicable, is MCA. So on this slide, you can see our ERD, which consists of 13 different entities. It was created based on the information given in the background. So all of the entities have primary keys and their own attributes. On this ERD, you can also see all the relationships between these entities. They are all already in one-to-many form, so there are no many-to-many relationships on this ERD. Let's keep on going with the normalization.
Thank you, Elena. The main purpose of normalization is to minimize redundancy and inconsistency in our database. And we are normalizing our tables into third normal form. During this process, we are looking into each table to be normalized. For the first normal form, each table must have a primary key, and all the attributes must be simple and atomic or indivisible. And also similarly, we can't have any multiple values or composite attributes in a table. Looking into our store table, we can see the attribute. We have a primary key, store number, and the attributes store name, store email, store phone number, etc. They are very simple and indivisible as well. And we can also see there is no multiple values. That means no repeating values in that table. Talking about second normal form, the table must satisfy or must be in the first normal form, and all the non-key attributes must be dependent on the primary key. Looking into the same table store, we can see store name, store email, store phone number, even fax number. They are all dependent on its primary key, store number. To be in to normalize in a third normal form, the table must be in a second normal form, and no attributes must depend upon other attributes in the table that are not primary key. That means the attributes can only depend on primary key. They cannot depend on each other. For example, same table, store table, we can see that store suburb and store postcode, they are actually dependent on each other, and that could be a problem because if we change the store postcode, the store suburb will change automatically because they are interconnected or interrelated. So in order to fix that, created another table called store postcode, and we have the attributes store suburb, store post, and store number. So that's the whole normalization process. I would like my friend Alina to discuss more about our table.
Yeah, thank you. So on this slide, you can see how we got rid of one of the many-to-many relationships. So because each store has many departments, as you can see, it has many-to-many relationship on the first left page of the diagram, and the solution for that we showed on the right side. So we introduced another entity, department stores, and it has primary keys coming from department, which is department number, and another one, store number, which comes from store entity.
Thank you, Alina. So after our ERD was created, our next task was to create a SQL file with all the entities, and creating table for each entity. So we use PG admin to create tables. Each tables for our database. And after creating the table, we also inserted values in each table, as well as its attributes. So in order to check if our SQL was running or not, and to further proceed with our task, we run our program through our PSQL tool, and everything was running fine. So we move on to our next part, and our next part will be explained by my friend Nigam.
So my name is Nigam Kumar. So I am discussing about queries. We have take two outputs from the queries. So the first one is that the list of full patrons, phone number, address in descending order of customer number. So then we run the select command in SQL to find out the customer name from customer order by customer number in descending order. So it shows the 5 rows of customer name, which is like Sub, Sunny, Ravi, Sami, and Samas, and there is a last name over there. So now I'm talking about the second SQL query. Yeah, so it is about the list, the customer number, name, address of all the customers, all the customer form, which has not been placed in any order. So then again, we run the select command in SQL from customer natural join orders. So it shows the output of customer number, customer name, and customer last address. So there's again 5 rows of customer name, number, and address, which is, we can see that they are same name when we find out in the first query one. So now I am talking about challenges. Yeah. So due to big data, the ERD takes a lot of time because it's a very complex, and then it's all fixed by Elena. So there are few many-to-many relationship between identities. Again, it is a very difficult to make the relationship between the entities, which is not converted very easily. And third challenge is due to combination of primary key and foreign key, the primary key gets violation, and it takes a lot of time to get it fixed. And the last one is when we run our SQL. So when we run our SQL, so it takes a lot of errors, get a lot of the errors. And when we do many time testing to find the errors and fix it properly. So the SQL is properly fixed by Sangeeta, and we help her to find the result of SQL. Thank you.
And that's it. Thank you very much for watching.
Thank you.
I hope you have a good one.
Thank you.